we are going to see in our environment and what are the field we want to study before doing the assessment. So, okay, this is a very brief introduction about who am I. I'm Matteo Beccaro. I'm a founder of a small company in Italy. We do offensive physical security. That's just my Twitter handle if you want to have, if you have some questions, if you want to keep in touch or whatever. Okay, this is our agenda for today. We will start with a little bit of introduction about what is NFC. Then we see a model of the transportation system, which can be useful later for the pen testing part. Then we are going to check what are the tools available to use and which are the most interesting ones. And then we start with the methodology. We will see what are the attack surfaces of the system. We will see what are the elements which are composing those systems, and then some vulnerabilities. At the end, to conclude the speech, I will show you some case studies of real-world scenarios I found in Italy. Okay, so let's start with NFC. What is NFC? I think most of you already knows that. It stands for Near Field Communication. It has a frequency of 13.56 megahertz, very short range, and can be used in access control system, ticketing, and mostly in mobile phones. Okay, so these are the most notorious families of NFC systems, technologies, sorry. And we have MyFair, which is composed by MyFair Classic, MyFair Ultralight, MyFair Desfire, and some other products. Then we have the HID I-Class, we have the Calypso, and Felica. So Calypso is very wide used in Europe for transportation system. I don't think it's spread here in Russia, but in Europe is a very common system, and since it is private product, it's under NDA. You can have documentation for that. If otherwise, you have to pay like 10,000 euros, so it's very difficult to do research on it. And Felica instead is very common in Japan, and again, I don't think here or in Europe you will see any Felica system. So I'll mostly focus on the first family, MyFair, because I think both in Russia and Europe you have MyFair Classic, MyFair Ultralight, and such systems. Okay, let's start with the MyFair Classic. As probably some of you already know, it is basically a memory storage device with some access control mechanisms, which are supposed to be strong, but it's not. There is a key which is required to read and write data from the sector and to the sectors. And the algorithm used is called Crypto1 and has been renamed by the researchers as Crypto1. As you can imagine from the name, the algorithm is broken. But even if it is broken, it is known broken for at least 10 years now, it's still widely used as access control system or in transport system. From my experience, we saw a company who create a new building in 2016, and for their access control system, they use MyFair Classic. MyFair Ultralight is mostly used in transport system. It's again a memory storage device with with less memory, just 64 bytes, and it has some basic security mechanisms which are supposed to help the developers of a transportation system in order to secure the ecosystem. So it has an OTP sector, which is a sector in which all the bits are set to 0 from the manufacturer, and then each time we turn one of those bits from 0 to 1, those bits is locked. We can do the reverse. We can turn the bit again to 0. In that way, we can easily store, for example, the number of writes we have left on our ticket as the number of 0 left on the sector. So each time we are going to stamp the ticket, one of those zeros turns to 1, and so the number of 0 left is the number of writes we have. Then we have the lock byte sector, which is a sector in which each byte or each bit of the sector represents one other sector of the token. And if we set those bits to 1, the sector represented by this bit is set in read-only mode. So we can't write on the sector anymore. And then we have like 46 bytes of data storage in which we can store like timestamp or other stuff interesting for transportation system. Okay, MySphere Deskfire is one of the latest products from MySphere. It has more advanced security mechanisms like FreeDES and AES. It has a file system structure, so we can have folders, we can have files, we can have counters for multiple use. And we have a quite big memory. We can have 2 kilobytes, 4 kilobytes, and 8 kilobytes. And there is several variants, Deskfire AV1, and Deskfire AV2 mostly. And Deskfire, the first version has been broken in 2013, if I remember correctly, from a couple of Germans guy from the University of Bochum. I don't know if I pronounced the name correctly. They found some side channel attacks in which they can reconstruct the key used for accessing the data from the power consumption, if I remember correctly. And then we have the HID I-class, which is divided into two variants, the standard one and the high secure one. In the standard one, the key used to access the token is shared among all the installations. So my installation of my own building has the same key of your installation. So all the readers sold by HID share the same keys. In high secure mode, instead, each owner can push its own key set to the reader in order to read and write its own device only. Both these variants are broken because someone was able to retrieve and dump the keys from the reader itself. Okay, let's see what a transport system looks like. We need to create a common methodology to perform professional assessment. We need to have this methodology to help us to have an efficient way to perform a penetration test on a transportation system and not lose time. We need to know what are the elements, and we need to know how to exploit those elements. To do that, we need to have tools, and we need some schemas to help our work. This is something similar to a common transportation system. I spent like 20 minutes to create this little man here, so I appreciate the effort. And anyway, the guy can use bus, metro station, or like train with the same ticket. The same ticket uses NFC technology, and the data and the identification of the ticket can be sent to an online, or anyway, to a cloud system, which can do some kind of operation, some statistics, stuff like that, and can also check between with an UID blacklist if our ticket is valid or not. So we have a remote part in which the data should be sent theoretically in real time in order to verify the ticket, and a local part which also verifies the ticket but just based on the data stored on the ticket itself. So these are two scenarios. We mostly found, at least in Italy, the first one, so local only. But it happened to find some system which use also the remote part. I think here in Moscow they also use the remote part. They have some sort of back-end system which checks the ticket somehow. And going more in details, we have something like this. We have our, oh, you have also the razor, sorry. We have some token, in our case is the NFC card. We have readers, some from the bus, some from the train, some from the metro, which communicate with some channels to a controller, which usually is in the same device as the reader. The controller, which does the offline validation, is the same device as the reader. And then we may have a channel which communicates with the backend system and eventually with some clients. The clients usually are some web application or some computer application used, for example, to recharge the ticket when you go to a shop or when you go to the train shop or whatever. Okay. This is an example of a ticket from a company here in Italy. Here, not here, but in Italy. And it just says ticket, city, and over the city, five travels. It's a NFC card, it's a ultralight card, and it stores, like I said, multiple rides, in this case 5. It stores a timestamp of the last stamp of your ticket, so they know when you stamp it. They also know where you stamp it, if you stamp it on the train, if you stamp it on the metro, and also the exact line in which you stamp the ticket. And it stores also other data. In my experience, we saw MyFair Classic implementation, which mostly are broken. We saw MyFair Ultralight implementation, which can have 3 main problems I will explain later. And then we have the Calypso implementation, which is under NDA, so I can't tell you anything of that. But I am available for questions later. Okay, as I said before, usually the reader and the controller are in the same device. In this case, this is again a real device from Turin, my city. You can stamp the ticket here. The device do some validation, and it tell you a feedback from the screen. In this case, it operates offline. It's not connected wireless or wired. Supports multiple standard because this reader supports both MyFair Ultralight and Calypso cards. And its purpose, again, is to check if a ticket is valid. If so, they stamp the ticket. If not, they refuse to stamp it. Of course, it stores secrets and key. In this example, it stores the keys of the Calypso implementation because MyFair Ultralight has no key for accessing the data. And so if we can obtain in some way one of these devices, we can try to extract those keys like has been done for HID high-class systems and try to see if we found something interesting. This is what I call the cloud, and it's the backend. The backend system can do several operations. Usually is the worst part during a pen test because you don't know what it is, you don't know exactly what it does, and usually it kicks you in the ass. So from my experience, it does statistics so that the company can know how many tickets they sold, how many tickets has been used, what are the lines most used, what are the lines in which there are too many buses and whatever. Can update the reader firmware, and can do some fraud detection and fraud prevention. Okay, the tools. I gave a workshop yesterday. Some of you recognize the faces. If you saw my workshop, I show some of those tools. If you go to the hardware village, they have some of them. They can show you. It's interesting place. So in my work, I mostly use those 4 tools: the HydroNFC, the Proxmark, the Chameleon Mini, and NFC Cult, which is an Android application I developed in the past. And well, each tool has its own advantages and disadvantages. I'll try to give you a very quick overview. I don't know what time is it. perfect. We are perfect in time. So, Hydra NFC. It costs about 90 to 100 euros. Use this chipset here from Texas Instrument. It has a very good documentation. At the moment, the firmware can do MyFair and 14443A UID emulation. You can also do, actually now from a couple of days, you can also do MyFair Ultralight emulation. It has a very interesting mode which is called sniffing mode that you can operate also in autonomous mode. So basically you can put this antenna between a reader and a token, and when you read or stamp your ticket, you can see what data are communicating between the reader and the token. So you can see if there is some secrets in the communication, you can intercept the communication, and the interesting thing is that the Hydra shows you who sent what. So you know that this data has been sent from the reader, and you know that the other data has been sent from the controller. It also supports a raw mode in which we can send like commands for unknown protocols, and we can also like modulate our protocols if it is on the 1356 megahertz. Of course, it's still under heavy development. This is the Twitter handle of the guy who developed the Hydra. You can help him, he surely appreciate it. And on that link, I don't know if anyone can see it. Anyway, on that link, you can find more information, the specification, a forum, or whatever. Okay, this is the Proxmark 3. In the picture, you have, I think it's something like a Chinese clone of the Proxmark, which costs like half of the price. It has high frequency and low frequency capability, which means it can operate both on 13.56 megahertz and on 125 kilohertz. It has a very big community. So in the link, you see the forum. There is a lot of people who work on the device, and it supports almost all known RFID tags. It supports sniffing, again, like the Hydra, and support also emulation. The disadvantage is that it's not very stable. Sometimes it can just crash, and it costs twice as the Hydra. Okay, the Chameleon is the first tool I used in my experience. It is created by the same guy who broke the Deathfire, as I told you before, and it also works only in high frequency, so 13.56 megahertz, almost the same capabilities as Hydra NFC, but a different chipset. And in the old revision of the hardware, those chipset is less stable than the Hydra. They also done a Kickstart campaign to get found to create a new revision of the hardware. They succeed in the campaign, so probably in the next month we will see new hardware revision and new firmware. At the moment, I found only the firmware for the old hardware revision, and on the website you can find more information about who are those guys and what they've done. Okay, this is, again, my application. It costs €0. It's a mobile application for Android smartphones. Its aim is to provide some help during assessment. It can't do all the works alone, but it can give you some quick help if you are in a hurry, for example. It automatically implements free attacks on MyFair Ultralight. And it has also a custom edit mode in which you can edit bit by bit each sector of ultralight tickets and try to see how the system behaves on those modifications. And at the moment, again, supports only MyFair Ultralight, but I plan to release a version with the support for MyFair Classic during the summer. Okay, this is just a couple of screenshots of the application. This is what with the screenshot of the lock attack, what the lock attack does. The lock attack set the OTP page that I said before usually stores the number of writes left in read-only mode using the lock byte sector. What does it mean? It means that if the reader tries to remove one write from your ticket, but the sector is in read-only mode, and the reader does not check if the sector is in read-only mode, then he tries to increase the number of ones, but he can't because the sector is in read-only mode. So he think he stamped the ticket, but actually you have the same number of writes as before. In 2 words, it means 3 writes. Okay, time attack is actually very simple to understand. We just need to find and decode how the timestamp is stored on the ticket. We found several implementations in which the timestamp is stored in clear text, so not encrypted. And if you know where it is and how it's stored, you can just set the application behavior to perform the same operation of the reader and stamp the ticket by yourself. What does it mean? It means that once you have stamped the ticket, you have like 90 minutes, 100 minutes of writes you can use. And again, 3 writes at the end. Reply attack is the latest one. It requires the use of a magic ticket, a Chinese clone of my Firewall Ultralight, in which all the pages are editable, and there is no such a thing as a OTP sector, no such a thing as lock bytes, no such a thing as UID. I mean, there are those things, but everything is editable. So we can modify the UID, we can revert the OTP operations, we can revert the lock byte operation, we can do whatever we want. With this attack, we can bypass all the offline anti-fraud prevention mechanism. For example, let's suppose our ticket has the timestamp encrypted, and it checks if the OTP sector is writable or not. So it prevents the first 2 attacks. With these attacks, we can just clone our legit ticket on the Chinese clone, increase the number of writes of 1, stamp it, and then we get the exact same data as we stamped the old ticket, but without modifying the number of writes, because we increase the number of writes by 1. When we stamp, the number of writes has been decreased by 1, so at the end we have the same number of writes, but valid timestamp, encrypted, but is valid. So we can move the timestamp to the legit ticket and use it for, again, 90, 100 minutes or whatever. So with that attack, again, we have 3 writes, and there is, at the moment, as far as I know, no offline anti-fraud prevention mechanism that can prevent fraud with this attack. Okay, then we have the custom edit mode. I found that mode very useful to understand the architecture of the data saved on the ticket. For example, for the time attack, we need to know where the timestamp is and how it's encoded. With this mode, we can edit each bit of the memory and try to understand how the system behaves to this modification, how the system adapts to this modification in order to understand where the timestamp is and how it's encoded. Most of the time, the timestamp is just the number of minutes, the number of seconds from a certain date. In this way, we can find that date very quickly. You can also perform just simple operation between, for example, X to bin to see the number of zeros left. It can be useful during a real-world assessment. Okay, let's go with the most interesting stuff, in my opinion, the methodology. This is the same schema as before, and my methodology works on the token, works on the reader, the controller, the backend, and the client. We try to create a common schema in which we can reconduct all the existing ecosystem in transportation system in order to have the same methodology to assess all of them. For example, let's speak about the stamping machine. The stamping machine is the reader plus the controller, usually. And we have attack surface, which is composed by an NFC interface, the hardware board, an eventual GSM, GPRS, Ethernet interface for communicate with the backend. for this attack surface, we have some attacks we have to perform each time. For example, analyzing timestamp mechanisms to see if there is some of the issues I showed before. For the hardware board, we need to analyze the exposed interface, hardware interface like JTAG, UART, if there are some USB interfaces, some forgotten pins or whatever. And for the connection with the backend, we need to see if some man-in-the-middle attacks is possible, and if we can intercept the data, if we can edit the data, what data is passing to the backend. And the impact for those attacks are, for example, free tickets, can be secret dumping, so we can get, for example, the keys for that specific implementation or for several implementations as well. And here we can intercept secret and sensitive data. It happened one time that on a different system, they use MyFair Classic. Inside the ticket there was the name, the DOB of the user, there was even the address, the residential address of the user. And all those data were being transmitted in clear text to the backend to perform statistics, I think. So it was very easy to intercept. They were using a customer radio frequency protocol. Once you understood the protocol, you can intercept the data and you could get like very interesting information about the people on the bus near you. So you know the name of everything sitting by, you know where they live. It was very interesting. Okay. Vending machine. Vending machine, one of the most interesting target from the company point of view, because most of the frauds doesn't happen from the users, but from the people who are supposed to charge your ticket. A lot of people charge your ticket, doesn't communicate to the company, and so the company loses money. So from that point of view, we wanted to know how the recharging mechanism happens, if there is some way we can bypass the paying part, let's say. Again, the hardware board to analyze, again, exposes interfaces, dump secrets, dump firmware, and then perform like assessment on the firmware. The communication interface to the backend, and then also the computer application. Again, a real case scenario where one of the clients were using a small computer to emulate the behavior of the backend, and since the computer application doesn't check if the backend is the real backend with some sort of certification, some sort of signatures, it could easily send fake data to this emulated backend and charge the ticket without declaring the charging to the company, to the transportation company. So it was basically charging you money for recharging your ticket, but it was not paying that money to the company. So this one was a very big issue for the transportation company. Okay, then we have the backend, which usually is used by the transportation company itself. They may have some web application to perform, to check the statistics of the use of the system, and so we can do just a standard web application pen test, network services, standard network pen testing, and one very interesting thing is the physical location of the backend. It happened twice that the physical location of the server was outside the building. I mean, there was a perimeter, and inside the perimeter there was the main building. The servers were located outside the main building, inside the perimeter, but outside the building. So if you can just walk inside to have like a guest appointment to the people of the company, and then when you go out, you see the server, you can attach to the server like a USB keyboard or whatever, and pawn the device. Okay, so now we will try to apply those methods to a real case scenario. Uh, I won't make any names on the companies, I won't make any names on the clients, but these are all real stuff we found in the past. Let's start with a MyFair Ultralight ticketing system. This is again our schema. We focus on the colored part, so token, reader, and controller. We won't pen test the backend system. The client asked us to not do any pen test on the backend system and any pen test on the client side. Okay, this is actually a dump from that system, the ticket. The blue part is the ID of the ticket, and there was no blacklist, so everything operates offline. So they cannot detect fraud from the backend. They don't have statistics. They didn't have anything. It was a very basic system. This is in red is the OTP sector I told you before, so it stores the number of writes left. For example, here we have 0 writes left, because everything is F, so if you transform in binary, everything is 1, we have no 0 left, so no writes. And in this system, the lock bits of OTP sector is not checked. That means that the stamping machine does not know if this sector is writable or not. And then we have the timestamp. Those are the timestamp. They store 2 timestamps because the same system was used both from bus and for metro. So in one of those is for metro and the other one is for buses. And timestamps are not encrypted nor signed. They are just the number of minutes passed from a fixed date. So we can just understand what is this number, increment it and stamp it at the moment to get free writes. So this was like the worst system we saw. There was no security mechanism whatsoever.
What's the other data?
Sorry?
What's the other data?
Oh, yes. The other data, here, this number here represents the line of the bus. So in this case, we were in the city center, one of the lines of the city center. This data here is just a fixed number that, sorry, not this one, it's just a fixed number that represents we are using a bus. The last timestamp of the ticket was stamped on a bus and not on a metro and not on a train. And here we have like a signature of which represents what companies has provide the stamping machine. So they know that this here means that the company was named, I don't know, XYZ and not ABC. And the other data I really don't remember. In some cases, we found that we can modify the statistics here, for example, or here, and crash the backend system. Because, for example, this is not the case, but in another system, the number was supposed to be at max, like, I don't know, maybe AA. We put FF. The system doesn't recognize FF and crash. So this is the most interesting stuff, but you can also look at the others. Okay, this is not a transportation system, but it's very interesting because it has the same issues of we can find a transportation system. It's a MyFair Classic door lock using one of the hotel. I did the same example yesterday at the workshop. And again, we focus just on the token in this case, just to show you how bad can be the token behavior in this case. Okay, that's it. This is the card UID, and this is the room number. Guess what happens if you edit the room number? Yes, you open other rooms. Also, in this case, everything operates offline. The room number, actually the card itself does not expire, which means if you stole one of the card and come back to the same hotel 1 year later, you can use the same card to open that room. And, well, I don't know what else to say. I can say. Again, question and answer is later. Was not a Russian hotel. was an Italian one. So if you want to visit Italy, I can give you some advice on the best hotels. Applause. It was nice. How many times? For yes, I'm starting a second company who basically does that, just resell tickets for free. It's a humanitarian company, you know, not-profit organization. Well, thank you. Okay, that's the applause I was talking about. Give the... You said 20 minutes? 2:45 or 20?
Yeah, you have 10, 15 minutes for questions.
So the organization, you already saw some talks, so you probably know that the best questions we receive are free T-shirts. One is black, another one is white. So best question, come on. He has some.
Hello. Do you have any experience by emulation of SkiPass data cards? SkiPass it's a ISO 15. I don't remember 293 or some else. Do you have any experience by emulation by Proxmark or by Asmicron Mini?
We had let's say a test which was not requested by the company against a ski pass system. They were using MyFair Ultralight, and we emulated with the Chameleon Mini. With the Chameleon Mini, we was able to go to ski. I live in a small city in Italy called Turin, which is quite near the mountains. So it was very nice to have this engagement, let's say. So yes, we have experience to emulate some ski pass with MyFair, mostly MyFair Ultralight and MyFair Classic.
And what about ISO 15? 15
Yes, yes.
93 cards.
It's possible. We didn't have any experience on emulation on that ISO. We did experience on reading and just cloning the car.
Maybe do you have experience with China's cards with rebreathable?
Oh no. We in our cases it was not necessary. We just cloned the car. The UID was not checked, so just the data matters.
Thanks.
No problem.
Three questions. So the first one is.
Wait.
So the first one is. Have you met in real life cases when cryptography is used to protect data on cards? So probably the data is stored encrypted with non-symmetric cryptography, and like the key is on the device to just decrypt it, because it just defeats every attack of rewriting the card, right? Rewriting the data on it.
Yes, we had some experience on encryption, asymmetric encryption on the data of the car. For example, as I said before, the MyFair Ultralight has no encryption by default. So what the company did was encrypt the data before sending to the ticket, and they were encrypted with asymmetric signature. They were encrypting and putting also a signature of the data. What we did was using the Chinese clone ticket to let all the work be made by the stamping machine. So the stamping machine was stamping the ticket with valid data for us. We just have a clone ticket in which we can increase the number of rides whenever we want. It's okay?
Yeah.
Perfect.
So, and the second question, if you have a device that just sends the data you want through NFC, you don't really need to change anything on the ticket, right? Because you have just a device that just sends the data. You don't have to modify, I mean, lock or unlock bytes on card, for example, because you just have the device that instead of card would send the data meaning?
You mean like emulation?
Yeah.
Yeah, that's true. You can also like one of the interesting thing we want to develop is something like fuzzing with the emulation devices, in which we fuzz the NFC interfaces of the readers of the readers of the bus, so we can try to send malformed data like the one who crashed the backend system, as I told you before. So yes, we can also use that method. Yes.
And there is a hardware that does it.
For emulation, yes, we have the hardware I showed you before. Wait. Okay, the Hydra NFC does partial emulation, and probably in the future we'll do full emulation of NFC system. The Proxmark can do emulation, and the Chameleon Mini can do emulation.
Yeah. Okay. So the last one. You mentioned that there is probably a GSM or GPRS connection between the station that verifies the card and the backend. So did you somehow really sniff that data and during your pen tests?
Yeah, we create a Rouge GSM station, and the reader machine connected to the Rouge GSM station and send the data to us.
Yeah. So okay, thank you.
Yeah, but it happens just once because it's not very easy to get the company allow you to do that.
Can I tell a very brief story about my experience with?
Of course. Please come on stage so anyone can see it. This is Meta Theater. Applause for him.
Well, this is, I think, is very usual and common history for small provincial towns from where I am, and we have no such system where we have a metro, we have a tramway, or we have a bus. We have only bus, and we have only the system. This card is MIFARE 1K class card. That's a secret. Well, I think you can ask me that later. When I buy this card, operator, the seller that sells, takes its read and registers in the backend. That this card is registered in and online. So I bought from, everybody likes it, AliExpress, for $40 reader, AR122. It's very common and widely spread, and used software called NFC UK. It uses vulnerability that if you have only just one sector with open key, with some default key like every F's or every zeros, it can for about 20-30 minutes crack the other A and B keys. We have two types of keys in the MIFARE cards, A and B. We can, with special bits, set privileges. For example, A key can only read, B key can read and write, and so on. So I get to these keys and dumped this card with my mobile phone. And I saw that the data inside is very primitive, and it's written even not in hex. It's written in decimal notation. It has a date, for example, of the last transaction, for example, some date, and the sum of left on the card, again in decimal notation. But it was only for example, 919 rubles only, not more than 1,000. I didn't risk and didn't write there. But after several users, they found it and started to blacklist. So every stamp machine, in the end of the day, when the buses came into the base, they dumped logs from there and compared if by the differences between 2 days. I think if the card is expired, it has 0 rubles, so we can't use it anymore, and blacklist by the UID. I didn't use any Chinese cards with a writable 0 sector.
Nice.
So it works, but it didn't work. I think only works for only 1 day nowadays.
Yeah, that, as I said before, when we have only offline situation, everything is doable. When we also have a backend system who checks that data, it's something more complicated. One of the tests I will do in a system, for example, is to provide some fake UID to see if the system accepts it, or try to populate the backend system and with the fake data to try to force the company to remove this blacklist stuff. Then I don't know exactly how the system works. So nice experience. Thank you.
But, can I ask a question?
Sure.
Just a short note. Yesterday I presented on Fast Track how we managed to crack Troika keys. Troika is the largest transportation system in Russia. And we even didn't need to have any sniffer for that, because there was a top-up application NFC for mobile phones with NFC. So what I did, I just actually sniffed the HTTP traffic, SSL traffic, and we found out that they had keys transferred from the server to the mobile application in base 64 format. So it's
So strong encryption.
yeah, so it's not even an encryption. Yeah, but anyway, I wouldn't be so optimistic regarding making free charge in Moscow, because unfortunately, or luckily, I'd say, they use message authentication codes. So you cannot change number of rights, unfortunately, because every data is checked. But what usually school kids do in Moscow, because Troika keys are well known, there's no diversification mechanism. So if you crack one key, you crack all the system. And what school kids do, they call it time machine. So you make a write, then revert data back, and make the second write. Of course, your card will be blocked in 24 hours, but during this time you can have plenty of writes.
Sure.
But my question is that, first, I didn't understand where you got a validator, because it's quite difficult to steal it from a bus in Russia. So probably that's why maybe you're planning to emigrate to Russia and become the second Snowden if you did it in Italy.
In our experience, we didn't steal one. We thought when I was a little boy to steal one, but when we get the engagement, they gave us one of the validators, one of the stamping machines.
Provided by
yes, it was provided during the real engage.
Okay, unfortunately, our Department of Transport is not so generous to give their validators for pen testing, I guess. And but actually, my question is that, as far as you know, probably that recently there were a new vulnerability discovered for MyFair Plus cards in SL1 mode, and there is a firmware for Proxmark 3.
Yeah.
But,
you can find information on the forum.
Yeah, but what about Hydra NFC? Do you have any plans to develop a firmware to exploit this vulnerability for Hydra NFC? Because I have Hydra NFC, but I don't have Proxmark. I would like to use this.
I'm in contact with the guy who is behind the development of Hydra NFC. Actually, he's working on MyFair Classic standard implementation to be able to emulate and to be able to read and write data. I think that with time, probably also that mode will be developed. The problem is that there is just one guy behind Hydra NFC development, while in Proxmark we have a huge community with very skilled guys, and so it probably will require more time.
But it's open source, so
yeah, it's open source. Everyone can do that. I have not the expertise to program it. I don't have the time to do that. But if some of you want to join the field, want to join his work, everything is open source. You can find GitHub on the website of the Hydra and develop your own modules, add it to the GitHub and share it. So
thanks.
I hope so.
Thank you. I understand.
I think we are running out of time. Yeah, they told me. Final question.
You have seen us broken system, but have you seen well done systems too?
Yes, we did. I mean, there were always we found problems. Sometimes those problems were not unfixable or very difficult to fix. And sometimes we found that problem were already been fixed by background operation we didn't see. So we report the problems, and the company said, okay, that's really a problem, but we have this mechanism to prevent it. So we said, okay, let us test also the mechanism, but that's another story.
Because we are all techie, and we forgot that the world is managed by financial people, and every secure system has a cost, and sometimes this is too expensive, and we need to manage it.
Yes, since we are speaking about frauds, mostly the private companies are very interested in secure their product before selling, because otherwise there can be some, bad behavior with the clients, with the final clients, which are the transportation system.
But I mean, sometimes secure system is too expensive.
Yes, that's true. That's true. So thank you, everybody, and I have to give you the T-shirt. So thanks. So there was a question from this guy who.
I will ask in person.
Okay, so you win a T-shirt. Black or white? Okay, I have another T-shirt. You didn't make any question. Fair enough. What color?